Good evening, everyone. So, good evening, right? Give me 1 second. Good evening, everyone. So, good evening. 1 second, okay? Right. Give me 1 second. All right. So we'll start our second theory class. I think first week we gave a kind of small introduction regarding the subject. Then last week, that means second week only, we started teaching the lesson, unit 1. And also we have done only for 2 hour class, and we gave a good introduction for the unit section, and we have done some theories there. Right, today is our second theory class day. Today our plan is to complete unit section entirely. Today we are learning some important theory points, and also right, today we are planning to start dimension section also. Right, when you're comparing with unit section, dimension section is somewhat complex, but not no need to think that much about the section. Don't worry, I will teach you from A to Z. So what I want to say is, when you are joining for a session, it's your responsibility. Since you are joining via online, it's your responsibility to stay focused, keep your focus, don't deviate your focus. And always I'm telling that spend whatever the time that you are spending, please, that's a kind of investment. Therefore, when you are spending your precious time for something, do that something with your best. Right, just because you are joining for a session, don't join. Always keep a motive that whatever the theories that I'm going to learn today, somehow I will understand each and every point clearly, and I will spend this time very effectively. That must be your ultimate goal each and every class when you're joining. Right, that story. Okay, so then when we go back to the last theory class, what we have done, we talked about physical quantities. Right, then if you give a small brief about what is physical quantities, we talked about any change happening in the surrounding. If you can measure it directly or indirectly, and if you give a name for that, that's going to be a physical. Time, force, velocity, they all fall under physical quantities, right? And also we talked about when it comes to physical quantity, then we can describe three main stories. All the physical quantities, they have a magnitude. Then when mentioning the magnitude, all the physical quantities requires a unit system. And also some physical quantities, they require direction also. Then based on the requirement of direction, we categorize physical quantities into two categories. One is vector, other one is scalar. If I give a small brief, if I write some stories, a small recap about what we learned last week. If I write a small recap regarding the things we learned last week. Last week, a small rough theory once again, one last time. Then we know the definition of physical quantity very clear, right? That idea is very clear. That is very clear. Physical quantity definition is very clear. We can categorize physical quantities into two categories. So one is scalars, other one is vectors. Physical quantities, we categorized into two categories. One is scalars, and the other category is vectors. Scalars, the other category is vectors. What is the main difference between scalars and vectors? We all know that scalars, they only have the magnitude. When describing some physical quantities only, explaining magnitude of the physical quantity is sufficient. For example, mass, length, time. Then we talked about vectors. When describing some physical quantities, only mentioning the magnitude of the physical quantity is not sufficient. We should define a direction. Then only we can get the exact meaning, exact idea of the physical quantity. I explained the force. If you just explain apply 500 force, then that doesn't make any sense. So you should mention apply 500 force to the right side direction, upward direction. Therefore, some physical quantities, they require a direction also in addition to magnitude. They are vectors. That idea also we know. Scalars, vectors theories we learned. Right. Then we talked about unit system, requirement of unit system. Then we talked about SI, Standard International Unit System. Right. Some stories, some ideas, a small kind of quick recap. If you go with a kind of quick recap, today we are learning lots of theories. Stay focused. I hope that most of you have taken the printouts of the PDF. And right, students who requested tudes, I think we posted already. Right, some of you might have received the tudes. If not, just put a small WhatsApp message in the group also. In case if you haven't received the tudes yet, then put a WhatsApp message. Others, I'm assuming everyone have taken printouts of the tude. Okay, if you are in the group, I shared the PDF version of the group. PDS version of the PDF ni question I send in the group also. Right, okay. The difference is scalars means they only have a magnitude. So they have a magnitude. Scalars, they only have a magnitude. They only have a magnitude. Only magnitude. Right? Only magnitude. Only magnitude. But vectors, they have both magnitude and direction. Magnitude. If it is a vector, vectors, they have magnitude as well as direction both. Magnitude and then direction both. Direction both. Magnitude and then direction both. This idea is clear. And if you put few examples for vectors and scalars, the best example for a scalar is mass, length, time, volume, density, blah, blah, blah. Right, example, you can tell that example. Examples, we all know. Right, examples. I will put one example because we learned last day. Mass, the scalar. Why it is required? This mass requires only magnitude to explain the idea. Vectors, the best example is force. Other than force, velocity, acceleration, displacement, linear momentum. We will talk, don't worry. In upcoming sections in Unit 2 to Unit 11, what we are doing is, we are learning each and every physical quantity. Every chapter, mechanics, oscillation waves, and heat, and in gravitational field, right? All the units, what we are going to do is, we are going to learn about the characteristics, equations, definitions, and calculations linked with all the physical quantities. So therefore, don't worry. Right? Example is force, no force. Then we talked about SI. Then this is the main idea. Then we talked about importance of unit system. Then we talked about standard international unit system, SI unit system. Then mainly we talked about SI unit system. We can categorize into few categories. One is base units. Then we talked about supplementary units. And then last we talked about derived units, and especially we talked about derived units with compound name. I think we stopped the class there, and we have done a question, and I think from that question only we stopped the class. Today we are starting there onwards, but I will brief once again what we learned last day, and we are going to today's story. Okay, and if you want to clarify something, if you want to ask something, you can reply to this WhatsApp number. Okay, I will. This is my WhatsApp number also. If you want to ask any doubts, you can put in this YouTube chat also. If not, what you can do, you can ask and clarify your doubts via the YouTube chat. If not, you can put a WhatsApp message. Then also I can refer your doubts and all. Right? This is my WhatsApp number. My WhatsApp number. Right inside is okay. Okay. Right. Okay. Then we talked about physical quantities base. SI unit system, look here, very simple idea. When you consider SI unit standard international unit system, right? So we can categorize mainly SI units into three main categories. Mainly, there are different categories. Mainly, SI unit system we can divide into three main categories for our understanding. We talked all those three categories. The first category is base units. Base units. Base units. Right, I told you there are 7 base quantities. So therefore there are 7 base units. You must remember, what are those 7 basic quantities? What are those 7 basic quantities, if you can remember? There are 7. There are 7 base units. What are those 7 basic quantities? What are those? Number 1 is mass, number 2 length, number 3 time. Number 4 temperature, number 5 current, electricity, number 6 luminous intensity. Last one is amount of substance, amount of matter. You must remember these. You must remember these 7 base quantities. You must learn by heart. There are 7 base quantities. There are 7 base quantities. Number 1 is we all know that mass. You must remember its SI unit is what? Kilograms. I told you simple K, simple G. Kilogram, simple K, simple G. Then number 2 is what? Number 2 is mass, length, time. Mass. And number 2 is length, second base quantity. Then what is the SI unit, base unit for length? That is, we know meter, simple length. A small recap, okay, small recap, meters. Then mass, length, number 3 is time. Number 3 time. Then number 4 is what? Temperature. Temperature. Number 5 is current, electricity. Electric current. Electric current. Number 5 is electric current. Electric current. Electric current. And then number 7. Number 6 is going to be luminous intensity. Luminous intensity. The last one is amount of matter, amount of substance. Luminous intensity. The last one is you must learn by heart these 7 basic quantities and they are base units. You must remember. Last one is amount of matter. Amount of matter, amount of substance, whatever. Amount of substance, amount of matter. Right, there are 7 base quantities. Then the SI base units going to be mass is measured in kilograms, simple K, simple G, length measured in meter, simple lim, time measured in simple S, second, simple S, temperature measured in kelvins, capital K, you can remember we learned this idea. Electric current is measured in amperes, capital A, and then luminous intensity is measured in candela, simple C, simple D, and the amount of matter, amount of substance it is measured in mole, simple lim, simple O, simple L. This side we clearing. Parallelly, we talked about 2 supplementary quantities and its units. There are 2 supplementary quantities. One is plane angle, other one is solid angle. One is plane angle, other one is solid angle. One is plane angle, other one is solid angle. Right? Okay. Supplementary quantity. Supplementary units. Supplementary units. There are 2 supplementary units. One is plane angle, other one is solid angle. There are 2 supplementary units. One is plane angle, other one is solid angle. Number one is plane angle. What is the SI units to measure the plane angle? I gave a kind of definition for what is plane angle. I am not going to explain that today's class. The SI units to measure the plane angle is radian, rad, simple R, simple A, simple D. Then number 2 is solid angle. Solid angle. I explained what is solid angle also last week in our theory class. solid angle. SI units to measure the solid angles, remember, steradian, simple, simple r. Steradian, simple, simple r. This is the idea, right now. You must remember these 7 basic quantities and their SI units. And you have to remember supplementary quantities and supplementary units. This is, you must remember, you must learn by heart. And also lastly, we talked about derived physical quantities. Right, how did we define derived physical quantity? Derived physical quantities means there are a huge number of physical quantities. They are derived. They are defined from basic quantities. I explain for an example. When you consider area, area definition is what? Length into width. We know that length is also a basic quantity, width is also a basic quantity. Then this area is defined based on length. Area is defined based on the basic quantity called length. Then this area going to be a derived physical quantity. Area going to be a derived physical quantity. That idea we clear, no? Likewise, we have done, we have practiced some derived physical quantity stories. For our convenience, we can break derived physical quantities also into 3 different categories. But this is not a mandatory story. For our convenience, what we do, we divide derived physical quantities also into 3 main categories. One is 3 main categories. The first category is, remember, basic okay, supplementary okay, derived physical quantities. Next idea. This is what we learned last day, okay? A small revision, a small recap. Derived physical quantities. Derived physical quantities. Quantities. We can break into 3 subcategories for our convenience. Right, one is derived physical quantities with compound names. The first category is compound names. I will give the idea. Last I think we stopped from this section. Derived physical quantities with compound names. Compound names. Second category is what? Derived physical quantities with special names. Second one is derived physical quantities with special names. Compound name. Second category is derived physical quantities with special names. Special names. And the last category is what? Derived physical quantities with the mixture of these two. A compound special name, if not special compound names. The last one is special compound names. You will understand the difference between these 3 categories. You will understand in a while. Right, special compound names. Last category, derived physical quantities with special compound names. Special compound names. Special compound names. Special compound names. Right? Okay. This story also okay. Right? Okay. This story is okay. So now what is the difference? Okay. I understood what is base 7 physical quantities and its units. I understood what are the supplementary quantities and their units also I understood. Derived physical quantity also idea is clear. They are derived from basic quantities. Right, that idea also clear. We categorize derived quantities into 3 categories, special, compound, special compound. Now what is the meaning of? What is the idea of derived physical quantities with compound names? Compound names, remember, the units of such derived physical quantities are only in terms of units of base quantities. Right? Now these physical quantities have units in terms of basic units. Right? Compound names, remember, these physical quantities are having units in terms of basic units. For an example, you will know that. Let's say now this is area. It's a volume. Okay, area. Example 1, we all know that area. Area means the definition is, you all know, length into width. As I explained already, area means we all know that is equal to what? Length into width. Length into width. Length into width. This idea we learned last year. Then what is the unit of length? length is a base quantity, then units of length going to be simply meter. Basic unit, meter is a basic unit, meter is a basic unit. And width is also measured in meters. Why? Width is also a length, no? Therefore meters. Then what is the units of area? Meter squared. So very clear, area is a derived physical quantity. That is clear. Why? Area is defined in terms of basic quantities. Therefore area going to be a derived physical quantity. Clear? When you come to this unit meter squared, this unit is derived from basic units. Then we can call this as a derived quantities with compound names, no? Right? Why? This physical quantities unit is only in terms of basic units. Then we are calling this as derived physical quantities with compound names. That is clear? That is the idea. That is the idea. For an example, another example is we know speed is what speed means. We can remember speed means distance over time. Speed equals distance over time. What is the unit to measure the distance? Meters. Time is measured in seconds. Right? So then what is the units of speed? Distance measured in distance is basically a length. Therefore basic quantity. Therefore it has a basic unit meter. Time is also a basic quantity. Therefore its unit is seconds. Then speed unit going to be meters per second. Then speed is a derived physical quantity. When you check the units of the speed, that is only in terms of basic units, meter, second. Therefore we call this as a derived physical quantity with compound names. This one units are in terms of basic units. Therefore this is derived physical quantity with compound names. Right? This idea. Clearly? This story is clear, no? This idea is clear, right? Okay. Then I think we stop from there only. Then we can go to the second story. Go to the tutor and page number. If you go to the tutor and page number, I think better can someone respond everyone. This is the recap of what we learned last day. We took around 50 minutes and I give a small rough idea what we learned last day. From today's recap, every story is clear. Just put a small thumb something. If it is possible to put a YouTube chat also fine, put a small thumb, all good, all clear. If everything is clear, if everything is good, put a small thumb. If all clear, right? Mostly this month is entirely, I might conduct via the YouTube, and April onwards we are starting our usual theory classes via the Zoom, okay? If all clear, if everything is very clear, better can someone put a small thumb, no? If you have doubts, you can ask, you can clarify your doubts. Till the first break, keep your attention. Stay focused. Till your first break, stay focused and keep your attention. Stay focused and keep your attention. Stay focused and then keep your attention. That idea. That story. This idea is okay. Okay, no? All right. Okay. Right. Now go to the PDF. Now take your PDF and we'll talk about derived physical quantities with the special names. This idea. Okay. Now for an example, I will tell you, for an example, this category. Now, if you can remember, last day we found the units of force in terms of basic units. You can remember force means what? Force means the equation. We all can remember. All levels also we learned force means mass into acceleration. Right? Okay? And we can remember this idea. Now, if you want to clarify anything, you can ask. There is WhatsApp number also. You can respond to you can reply to WhatsApp number also. Right? Next idea. Right? Then derived physical quantities with special name. Special name. Right? Derived physical quantities. Okay, I just write on short term. Derived physical quantities with special name. with special name. Special names. This idea. Okay. Listen very carefully. Stay focused till the first break. Keep your focus and learn. Now, sir, we can remember last day we learned a physical quantity force. We all know force means what? Force means, we all can remember, force means mass into acceleration. Force means mass into acceleration. Mass into acceleration. Acceleration. Right. Then last day we found the units of force. Mass is measured in kilograms. Simple K, simple G. Mass measured in kilograms. Simple K, simple G. You can remember acceleration units going to be meters per square second. Right? Meters per square second. Kg m is minus 2. Then the units of force we found, units of force equals what? Kg m s to the power minus 2. Kg m s to the power minus 2. That is the units of force. But we all know that, sir, then this kg m s to the power minus 2 means derived unit with compound names too. Because this unit system is made with basic units, right? Kg is a basic unit. Meter is a basic unit. Second is a basic unit. Therefore, this kg m is minus 2 means this unit is made with basic units. Therefore, this is the SI unit with compound names. Do you understand? This unit is in terms of compound names. No, compound names. But we all know that there is a special name that we given for the units of force. We all know there's a special name given for the units of force. What is that? Yes, definitely units of force going to be kg m s to the power minus 2. This unit is made with basic units. So therefore we are calling kg m is minus 2 as the units of compound names. Compound names. But we all know that in addition to this unit, we all know very popular unit is there. There's a very special unit that we define for force. That is newtons. Right? That is newtons. To describe the force quantity, we defined a unit called newtons, capital N. Then remember, that is going to be the derived, Newton means what? Derived unit with special name. What's Newton? Newton going to be the derived units with special name. If not derived physical quantity with special name. That is the idea. So that is the idea, right? Then also you can remember now, once again if I tell, we all know that energy means what? Energy means, if you can remember, energy means, right, look here. Okay, work done. Another example is work done. Right, another example, work done. That is also a derived physical quantity. Work done. Now we can use newtons, no? To measure the force, we are using newtons. Therefore, this newton is what? Derived physical quantity with special name. This unit is with special name. And work done. Work done means, if you can remember the equation last we learned, work done means, remember, force into displacement something. Force into displacement. There's a nice definition for work done, but this level not important. Force into displacement. Then last we found what is the units of work done. Units of work done is what? The force is measured in kg m is minus 2. No? The units of force going to be kg m is minus 2. Displacement is also a length, okay? It's a length. Units of displacement is meter. Then if you find units of work done using compound names, if you find units of work done using compound names, going to be kg m square is minus 2. So this is we call as units of derived unit with compound name. This is what we call as kg m square is minus 2 as the derived units with compound names. That is clear? Because this unit system is only in terms of basic units. Now also you can write down, someone can write down, sir, work done means, I can write down work done as what? Work done, you all can remember, work done, we are using a special unit to measure work done. That is joules. Joules. Then remember this joules. That is we call as the joules. This joule is we are calling the units of special name to measure the work done. You understand the idea? That is the idea, right? I think idea is clear. Now go to the Tutan. Go to your Tutan. Go to your Tutan. Go to your Tutan. Go to your Tutan. Right. Take your Tutan page number in the PDF. Go to Tutan in the PDF. In the PDF. Now I think we discussed page number 1, 2 done. Page number 3 also discussed. Page number 4 completed. Go to page number 5. Page number 5. Derived units with special name. We'll complete the table, but remember one thing. Okay, after completing those two tables, I will tell you the idea. First of all, we'll complete the table. We'll complete the table. Okay, derived units with special name under that heading. First one is force. No, now force. Right, force. Okay, we'll complete the table. Quantity force, then special name of units. Okay, right. I will draw the diagram table. Quantity. Okay, so then special name, symbol, definition, special name, and symbol, then definition, definition, quantity, special name, symbol, definition, and other SI units and basic units. Other SI units and basic units. Other SI units and basic units. Last one is basic units. Basic units. Basic units. Right? Okay. Okay. Right, okay. Okay. Now number 1, write down first quantity is, they have given force, no? First quantity is force. Force. Then what is the special unit? What is the special name for the unit to measure force? Newtons. Newtons. Start writing newtons. Start writing newtons. Start writing newtons. Start writing. Newton. Symbol is capital N. Newton. Newton. Symbol. SI unit to measure force. The special name is Newton. Symbol is capital N. Right, symbol is capital N. Definition is what? Force means, just write down. Force means mass into acceleration. Definition, write down mass into acceleration. Right, mass into acceleration. Mass into acceleration. Acceleration, okay? Acceleration. Right, to measure the force, what are the other SI units? To measure the force, what are the other SI units? Right, normally, no. What are the basic, now to measure the force, what are the basic units of force? If you find the units of force only in terms of basic units, then we can remember basic units of force is what? kg m is minus 2. kg m is minus 2. kg m is minus 2. So this is the SI, units of in terms of basic units. But this unit is a special name. To measure the force, the special unit name is newtons. Likewise, number 2. Number 2, second one is write down. Second one, pressure. You all know that what is the special unit that we use to measure the pressure? Pascal. What is the special unit that we use to measure the pressure? Pascal. Pascal. The symbol is, let's say, capital P simply. The symbol is capital P simply. Capital P simply. Definition is what? Definition is pressure means, we can remember pressure means what? Force over area. Pressure definition is, pressure equation is force over area. Force over area. Right? Force over area. Force over area. Right, okay. Then to measure the pressure, what is the basic, if you find the units of pressure in terms of basic units, last we learned, if you can remember, the basic units to measure the pressure is kg, right, m minus 1 is minus 2. Kg, m minus 1 is minus 2. If you can remember, kg, m minus 1, s minus 2 is the units to measure the pressure in terms of basic units. Kg is a basic unit, meter is a basic unit, second is a basic unit. Now, the special unit name is Pascal, capital simply. What are the other units that we can use to measure the pressure? Sir, to measure the force, the special unit to measure the force is newtons, no? Area is measured in meters, no? Then I can write down another units to measure the pressure is Newton per meter square. The special unit to measure the force is newtons. Area means meter squared. The other units to measure the pressure is what? Newton per meter squared. Newton per meter squared. Capital N, simple m to the power minus 2. Newton per meter squared. Right? I think now the idea is clear. Right? Then number 3. Now we'll fill in the blank these two tables. Then we can talk some interesting theory points. Right? Then we can talk new interesting theory points. Right? Then we can talk new interesting theory points. Next idea. Next one, write down. Next one, work. No? Work. Number 3, work. Third one is work. Number 3, work. Number 3, work. Work. Then work. What is the special unit to measure the work? Joules. Joules. The symbol is capital J. Symbol capital G. Symbol capital G. Right? What is the equation? If a definition to measure the work, definition for the work is what? Definition for the work is force into displacement. Force into displacement. Force into displacement. Force into displacement. Displacement. Right? You complete. Okay, now I can write now. Force into displacement. You complete the sentence. Okay, this term, displacement. Right. To measure the work, the special unit is joules. Symbol is capital J. What is the unit that we use to measure the work in terms of basic units? Last we learned that is what? Kg m squared s minus 2. Kg m squared s minus 2. In terms of basic units, the units to measure the work is what? Kg m squared s minus 2. Okay, other than this kg m squared s minus 2 basic units and other than the special unit joules, are there any other units to measure the work? Yes. Why? So force is measured in newtons and displacement is measured in meter. We can use Newton meter also as a unit to measure the work. Rightly? Work. Okay, then the fourth one is energy. Fourth one is energy. Remember, fourth one is energy. Fourth one is an energy. Number 4, energy. Number 4, energy. Remember, energy also, remember, pretty much similar to work. We will learn the relationship between work and energy. We will learn in our mechanics chapters. Energy. There is a kind of relationship between work and energy. Energy. The special unit to measure energy is again joules. Remember, work and energy both are measured in joules. Symbol is capital G. Symbol capital G. The definition of energy, remember, ability of doing work. Right, there is no any particular equation for energy. We will learn different forms of energy in our mechanics chapter. We will talk about different forms of energy, then kinetic energy, potential energy, elastic potential energy. Then you will understand these ideas. But just write down the definition of energy as what? Ability of doing work. Ability to do the work. Right like that. Right like that, okay, right like that. Now, after completing this table and one last table, we can talk some interesting theories. Okay, first of all, we'll complete this way. After complete these two tables, we can talk some interesting stories. Next one, ability to work. Just mention ability to work. Ability to work. You'll understand, don't worry. Then other essence is also Newton meter. Then the units in terms of basic units kg, same, m squared s minus 2. Right. Next one, fifth one. What is the fifth one? Fifth one is in the table, then force, pressure, work, energy. Fifth one, power. Power. You all know, you learn these theories in your O levels. Fifth one is power. Power, what is the special unit to measure the power? Watt. Symbol is capital W. What is the definition for the power? Power means we all know energy over time, if not work over time. Right, power means, remember, energy over time, if not work over time. I just write down work over time. Work over time. Detailedly, we will learn these definitions, equations in upcoming chapters, okay? Work over time. Just fill in the blanks. You don't think anything so much, don't worry. In case even you forgot these definitions also, completely alright. Just complete the given tables, that's it. I will tell you in the end what you want to remember and what you should not remember. I will explain, don't worry. I will give a guide. Then what is the units of power in terms of basic units? kg, m squared s minus 3. kg, m to the power 2, s to the power minus 3. This idea. Then what are the other units to measure the power? Just now we learned work is measured in joules. Time measured in seconds. Then other possible units to measure the power is joules per second. Joules capital G, simple is minus 1. Fifth one is what? Frequency. We all know this idea. What is the special unit that we use to measure the frequency? Hertz. Frequency. Special unit to measure the frequency is hertz. Hertz symbol is capital H, simple is it. Capital H, simple is it. Capital H, simple is it. What is the definition of frequency? 1 over time. Frequency means, remember, 1 over time, if not number of vibration over time. Remember, number of vibration over time. The definition of frequency is number of vibration over time. Right, write on here. Number of vibration over time. Number of vibrations, okay? Vibrations over time. That means, remember, number of vibrations does not have any units, but time as a unit per second. If you write the units of frequency in terms of basic units per second, s minus 1. The frequency does not have any other SI units. It does not have any other SI units. Right? Then last four. The last four. Electric charge. Seventh one is electric charge. Seventh one is electric charge. The special unit to measure electric charge is coulombs. Coulomb. C-O-U-L-O-M-B. But don't worry, okay, in case if you can't remember these things, so if you haven't learned such things, don't worry, I will teach you properly, don't worry. coulombs. Coulomb. Symbol is let's say capital C. Capital C. Definition is write down coulomb. The charge definition is write down, that is current into time. Current into time. Current into time. Current into time. Okay. Other SI units, just write down now. You know the idea what's really happening in this table. You understood, no? Right. No any other units, but basic units ampere second. Ampere second. Capital A, simple is ampere seconds. Current is measured in ampere. Time measured in seconds. Therefore, if you find the units of electric charge in terms of basic units, it's going to be ampere second. Capital A, simple is. Capital A, simple is. Last three, 8-1. Last three, 8-1. Write down 8-1, write down. 8-1 is electric potential. Electric potential. 9th one, electric capacitance. 10th one, luminous flux. Electric potential. 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 9th one is electric capacitance. Capacitance. Electric potential, the special unit to measure the electric potential is volts, capital V. Volt. Volt. Symbol is capital V. Right? Definition is what definition you don't understand, because don't worry, these sections, these physical quantities and their equation we will learn in unit 6, 7, 8, and don't worry. The definition is, remember, write down definition is, definition of electric potential, write down there. Potential, okay, work over charge. Work over charge. Work over charge. Right? Work over charge. Work over charge. And other assignments for electric potential going to be joules per coulomb. Work is measured in joules. Charge is measured in coulombs. Therefore, joules per coulomb. If you write this units for the electric potential only in terms of basic units, then it's going to be write down kg. It's going to write down kg. kg. M squared S minus 3 capital A1. Kg M squared S minus 3 capital A minus 1. Right? Kg M squared S minus 3 capital A minus 1. This idea. Right? 9th one is electric capacitance. Especially you need to measure electric capacitance is farad. Not parrot. Farad. F-A-R-A-D. Farad. It's farad. Symbol is capital F. Symbol is capital F. Symbol capital F. Write the definition to measure the electric capacitance. Definition is write down. Definition is charge over potential. 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 Other units to measure the electric capacitance is charge measured in coulombs, potential measured in joules, right? Volts, no? Potential measured in volts. Therefore, other units is going to be coulombs per volt. Coulombs per volt. Charge measured in coulombs, capital C. Potential measured in volts. Other units to measure the electric capacitance is going to be coulombs per volt. Capital C, capital V minus 1. Right? Then if you write down the units of electric capacitance only in terms of basic units, it's going to be write down. It's going to be kg minus 1 m minus 2 kg minus 1 m minus 2 kg minus 1 m minus 2, right? Then s to the power 4 and capital A squared. S to the power 4 1 capital is scared. This idea. Last one, 10th one, right? 10th one is last one, right? Last one. In your table given to last one, luminous flux. Luminous flux, write down the special unit to measure the luminous flux is right down there. That is lumen. Simple L-U-M-E-N, lumen. Lumen, simple L-U-M-E-N, lumen. The symbol is simple lim. The symbol is simple lim. Symbol. Definition write down. Definition is write down. That is luminous intensity into solid angle. Definition, luminous intensity into solid angle. Luminous intensity into solid angle. Solid angle. Solid angle. Other SI units write down there. Candela steradian. Luminous intensity we all know that is measured in candela. Candela. Solid angle measured in steradian. Other units, candela steradian. We can't write down units for the this physical quantity in terms of basic units. Right? That's it. Likewise, we'll complete one last table. Then I will tell you some stories. The last table. Then table completion story is more than enough. We can go to upcoming theory points. One last table. Then we understood what does it mean by physical quantities. Derived physical quantities, its special name very clear. We understood what is the meaning of derived physical quantities with compound names. Derived physical quantities with special name. That is also very clear. Then the last table going to be derived units with compound special names. I have given 5 physical quantities right on there. Number 1, thermal capacity. Thermal capacity. Right, number 1 is thermal capacity. Last table. Thermal capacity, the symbol of SI unit write down. Thermal capacity, the symbol of SI unit is write down. Joule per Kelvin. Thermal capacity number 1. Thermal capacity. Thermal capacity. Capacity. SI symbol is joules per Kelvin. Joules per Kelvin. The next column write down. Next column. Expression, the symbol, expression using SI base units. kg m squared s minus 2. kg m squared s minus 2. kg m squared s minus 2. Capital K minus 1. Number 1. Number 2 write down. Now these are the derived quantities with compound special names. Right? Next one write down. Next one. That is thermal conductivity. Thermal conductivity. Thermal conductivity. Thermal conductivity. What is the SI? Symbol of SI unit is going to be how? What is the symbol of SI unit? Symbol of SI unit going to be watt per meter per Kelvin. Watt per meter per Kelvin. In terms of basic units, it's going to be what? kg m s minus 2. kg m s minus 2. Right? kg m s minus 2. Right? kg m s minus 3. Okay? Capital K minus 1. Third one. Right? And third one write down. Third one is that is permeability. Fourth one, permittivity. Third one write down, permeability. We will, don't worry now, sometimes when you write this sentence, these terms, you feel like, so what the hell are these? We have no idea what is thermal conductivity, what is thermal capacity. I don't understand what you mean by electric potential, capacitance. We have no idea what you're writing. That is very common actually. This is what we are going to learn in our syllabus. From unit 2 to unit 11, we are going to learn about all these physical quantities. So therefore, it's 100% okay by reading some names. If you have no idea, it's completely all right. Because if I start explaining about what is electric charge, then I want to start today unit 6, electric field. If I want to explain what is permeability, then I want to explain magnetic field, unit 8. Then we are not able to, if I start unit 6, unit 8, then we can't complete unit 1. Right? So therefore, now this lesson explains some stories, but you don't try to understand the meaning of each and every physical quantity. If I want to explain that story, I want to teach you the entire lesson. Right? What you do, I will tell you what you're going to do. Right? Just write down the names and just understand what would be their units and just get a rough idea. Just write down, just fill in the blanks. That's it. Just fill in the blanks. After completing this table, I will tell you what you want to remember, what you should not remember, and what you want to remember. I will tell you. Permeability. Okay, permeability. Then the SI units what? Permeability. We can write down Henry per meter, capital H. Henry per meter. The SI units is basic units, kg. Right, kg, m s minus 2, a minus 2. kgm, s minus 2, capital A minus 2. The fourth one is right, and fourth one is permittivity. The SI unit is right down there. Okay, farad per meter. The units in terms of basic units. Kg minus 1, m minus 3, kg minus 1, m minus 3, S4, capital A is K hat. S4, capital is K hat. The last one, right? Last one, surface tension. Last one is surface tension. Surface tension. Then Newton per meter. Right, kg s minus 1. Right, that's it. Now, okay, sir, right, all done. Kg is minus 2, no? Okay, right, okay. Okay, till now you told last day also we have completed some tables, that is basic quantity, 7 basic quantity table, and the last day we completed supplementary to quantity table with their SI units, and last day we completed derived physical quantity with compound name table. Today we completed derived physical quantity with special name table and derived physical quantities with compound special name. Now remember, you don't need to remember these two tables. Right? So far, please don't remember these tables. You can't remember also. Right? We will learn each and every physical quantity and their units. We will learn in upcoming chapters. Once we complete each and every lesson, then you should be able to remember the physical quantities in the relevant lesson and their SI units and their dimensions. So far, only you remember that basic 7 quantities and their units, and the 2 supplementary physical quantities and their units, and just roughly remember what does it mean by a derived physical quantity. That is more than enough. Just to complete a theory, I explained these ideas and we completed some tables to make sure a proper note. Just we drew some tables and we have done something. That's it. This story is more than enough. Now next idea. Next theory point. Right. In your tute, then we discussed page number 5 also done. Page number 6. Right, okay. Page number 6. Okay, I'll give some time. Just refer what you learned from the beginning. Right, time is exactly 8:01. We start our class at 7 o'clock. I will give around 5 minutes. Just refer what you learned from the beginning. I'll give 5 minutes. Right, just refer from the beginning what you learned from the last week theory notes and today's discussion. What you learned from the beginning, just refer it. 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 We'll take a break around 8:40. We'll take a break around 8:40, okay? So then today we are planning to the class till 10 p.m. maximum. Keep on doing. From the beginning to now, refer everything you learned. Refer everything you learned till now. From the beginning. Refer everything. Okay? Refer everything. Just refer it. Now, if you have anything to be clarified, you can ask your doubts, right? Especially now when you are entering to A level from O levels, you have lots of doubts, you have lots of problems. How to do this one? Now, I have a doubt regarding subject selection. Sir, now how to study likewise? You can ask plenty of doubts. Whatever the doubt, if you have, you can ask with me, and then I can clarify. Okay. Just refer the entire theory note that you learned from the beginning. Then one last table that is not that much difficult table will come to the table and we'll talk about something important, points regarding the units. After completing one last table, we'll discuss the important points regarding unit system. Then that is finished. We can talk about prefixes. That is somewhat important section. After completing prefixes, we can start dimensions. Prefixes, then we can start dimensions. Okay. Right. Now, in addition to these SI units, very frequently in our day-to-day life, we are using some other units also. Still, we are in use. Yes, of course, to measure the time, the SI unit is seconds, right? But in addition to seconds, still we are using minutes to measure the time. Hours, days, years, we are still using to measure the time, right? Then we want to talk something, we want to talk some points regarding what are the other units which does not fall under SI units, but still we are using in our day-to-day life, right? Now, minute is not a SI unit, hour is not a SI unit, right? To measure the angle, we are using degrees, minutes. They are not SI units, but still we are using when we are doing some calculation. So therefore, we'll talk what are the other units that we are still in using in addition to SI units, that story. Okay, then the last table is units outside the SI unit system that are accepted, that story. Okay, now, right now idea, the last table, page number 6, units outside the SI that are accepted for use. Time, especially time, no? To measure the time, we can use different other units to measure the time, right? Time. Number one is time. Physical quantity, unit name, symbol. Physical quantity, right? The last one. Physical quantity. Physical quantity. Then unit name and symbol. Unit name and symbol. Next one is symbol. Right, symbol. The last table. Now these units does not come under SI units. These are addition to SI units, but still we are using when doing our calculations and in our day-to-day life. This idea. Right? Okay. Now first one is time, no? First one is time. Number one is time. The SI units to measure the time is seconds. In addition to the seconds, what are the other units that we are using to measure the time? Minutes. Then we can tell hour. Then we can say that the days, months, years, they are also units to measure the time, no? Then you can write down there. Right there. Right there. Right there. Minutes. Minutes means minute. Minute. The symbol for minute is what? Min. Simple name, simple as simple and min. Min. Then we can use hours. Hour. Symbol is simple h. Simple h. Hour simple h. Then days. Days means simple d. Days. Days means simple d. Now, when doing calculations, you should remember what is the relationship between 1 minute, 1 hour and 1 second. You should remember the relationship between minutes, hours and seconds. Right? Some theory points, okay? Some theory points. Right? Now 1 minute means, remember, you all can remember 1 minute is how much? 60 seconds. 1 minute means, remember, that is equal to 60 seconds. Okay, right? Then sometimes in a question they can give the time in minutes and they can ask you to convert it into seconds. Right? Remember, 1 minute is equal to 60 seconds. Okay. In the exams they can give the time in minutes and they can ask you to convert minutes into seconds. In that case, what you want to do is, remember, if you want to convert minutes into seconds, you should multiply the time given in minutes by 60. Right? If you want to convert, remember, minutes, the time given in minutes into the seconds, you should multiply it by 60. Right? Multiply by 60. Sometimes they can, very rarely only, they are asking the opposite. Sometimes they give the time in seconds and they ask you to convert into minutes. If you want to convert a minute into seconds, you want to multiply by 60. If you want to convert seconds into minutes, the rarely only they ask you to convert into seconds. To convert the time given in seconds to minutes, remember, you want to multiply by 1 over 60. You want to multiply by 1 over 60. Multiply by 1 over 60. Multiply by 1 over 60. Some theories, some additional ideas. Additional theory ideas. Right, please mark the stories. Now quickly take your CR book and take your notebook and just quickly convert these time into minutes and seconds. Do these conversions. Now quickly convert 120 seconds into minutes. And quickly convert, write 2.5 minutes into seconds. Number 3, convert 90 seconds into minutes. Do the conversion. Start doing. Just now we learned that 1 minute is equal to 60 seconds. Then please convert these given times in seconds and minutes into seconds and minutes. Just start doing. Start with the idea. Start doing. Keep on trying. Not difficult. You can keep on doing. Keep on doing. Keep on trying. Keep on trying. Keep on trying. Then it's 120 seconds. If I want to convert time given in seconds, and if I want to convert to minute, I want to multiply by 1 no 60. So to convert 120 seconds into minutes, I want to multiply this time by 1 no 60. Multiply by 1 no 60. Then 120 over 60. 120 into 1 no 60 means, remember, if you divide by 60, it's 1. If you divide 120 by 60, it's going to be 2, no? Then 120 seconds equals to 2 minutes, no? 2 minutes. Answer is 2 min. Likewise, convert this 2.5 minutes into seconds. If I want to convert the time in minutes to seconds, I want to multiply by 660. If you want to convert the time in minutes into seconds, multiply by 60. If you multiply by 60, 2.5, I want to multiply by 60. If you multiply by 60, then 25, 2.5 into 60 means, remember, 25 into 6. 60 means what? 60 means 6 into 10. 2.5 into 60 means some simplification stories. 2.5 into 60 means we can write down 6 into 10. Right? 60 means 6 into 10. And then 2.5 into 10 is how much? 25. 25 into 6. That is how much? That is equal to 150. 150 seconds. Answer is how much? 150 seconds. 150 seconds. Again, last one. Seconds to minutes. Multiply by 1 over 60. 90 seconds. If I want to convert seconds, multiply by 1 over 60. When you multiply by 1 over 60, that is going to be equal to 90 over 60. Right? 90 over 60. 90 over 60. These two 0 cancel out. 9 over 6. I can divide 9 and 6 both by 3. If I divide 6 by 3, here it's 2. If I divide 9 by 3, it's 3. 3 over 2 means how much? 1.5 minute. Finally, 1.5 minutes. Now, these are some basic ideas, but just for our understanding, once again, we are doing some calculations. And also, right, sir, relationship between minute and second is clear. What is the relationship between hours and minutes? Remember, 1 hour means 1 hour. That is equal to 60 minutes. 1 hour, if you convert to minutes, 60 minutes. Right? So if I convert 1 hour into seconds, then how much? In seconds, 1 hour means how much? In seconds. In seconds, 1 hour means how much? Right? Then 1 hour means 60 minutes, no? 60 minutes. 60 minutes means I can write down 60 into 1. 60 minutes is 60 into 1 minute. 60 into 1 minute, right? 60 minute means what? 60 into 1, 60. 60 into 1 is 60. Right, we know that 1 minute is how much? 60 seconds. Now we know here 1 minute is how much? This 60 is here into 1 minute. If I convert to seconds, 60 seconds. 60 seconds. Seconds. Then I can write down 1 hour is 60 into 60 seconds, 3600. 00. 6 into 6, 36. 1 hour means, remember, 3600. 3600 seconds. Seconds. Right? 1 minute is 60 seconds. 1 hour is 60 minutes. These things you know in your knowledge also. Just I'm explaining. Right, in case if you don't know these ideas, even you know also completely alright, just take your notebook and please put these stories in a notebook. Some people, when they are doing calculation, some students, they can't remember how to convert to minutes into seconds. They don't know how to convert a time measured in hours into seconds. They don't know. Right? 1 hour, if you convert to seconds, 3600 seconds. This idea. Right? Then try to convert these stories. Okay, these stories. Okay, these stories. Right now, if you want to convert a time hours into minutes, if you want to convert hours into minutes, you can what you do? If you want to convert a time given in hours into minutes, you want to multiply by 60. Multiply by 60. The opposite, if you want to convert a given time in minutes into hours, if they have given a time in minutes and if you want to convert to hours, remember multiply by 1 over 60. Multiply by 1 over 60. 1 over 60. Right? Let's say now the time they have given in hours and you want to convert seconds. Then you want to multiply by 3600. If you want to convert a given time in hours, if you want to convert it into seconds, multiply by 3600. Multiply by 3600 some stories. And remember, very rarely only the opposite is happening. If the time is given in seconds and they are asking you to convert into hours, they remember multiply by 1 over 3600. Multiply by 1 over 3600. Multiply by 1 over 3600. Some people have a problem, sir. Why you are telling, okay, right, for an example, this story, to convert minutes into seconds, multiply by 60, okay. To convert seconds into minutes, we should divide by 60, no. We should divide by 60, no. Why you are writing multiply by 1 over 60? Some people have a problem. Right? To convert seconds into minutes, we should divide by 60, no. Why are you writing again multiply by 1 over 60? Division 60 means we all know, all of us will learn. Division 60 means multiplication, the reciprocal of 60, 1 over 60. Dividing by 60 equals multiplying by 1 over 60. Is that clearly? Is that is okay? Right, now these are some important stories. Important theory points, write down somewhere else. Actually, I was explaining about, in addition to the SI unit system, to measure the physical quantities, we are using some other units also, especially time, SI unit is second. But in addition to the seconds, we are using minutes to measure the time, hours and days. Now, remember 1 day means 24 hours. Remember 1 day means 24 hours. 1 day means 24 hours. 24 hours. This idea. Okay. Likewise, number 2, right? Now, these are important stories. You can learn something from these ideas. Right. Next section. Next idea. Then in the go to the graph. Go to this table line. Next one is angle. To measure the angle, plane angle, we are using the SI unit to measure the plane angle is radian or radi. But in addition to radian, we are using degrees. If not minutes to measure the angle. Degree, minutes to measure the angle, not the minutes that we are using to measure the time. Right? Even when we are measuring the angle also, we are using a unit called degrees, no? Right? Then write down plane angle means degrees, minutes and seconds. To measure the plane angle, SI unit is radian. But we are using, most of the scenarios, we are using the degrees. Right, degree. Then minutes. Then second. Now don't misunderstand, this minute and second is the units to measure the time. These are even though these terms are used in to measure the time, but these are different meaning. These are having different meaning. The symbol is, you can remember, symbol is degree means what? Degree means we can remember a symbol like this, no? A symbol like this, degree. There is a symbol to me, 30 degree means we all know 30 degree means we put a symbol like this. 4 degree means a symbol like this, no? Degrees. And minute symbol is what? Minute symbol is, right, we are writing the angle and the symbol is something like this. I think you will learn the stories in your levels. And second symbol is like this. Second symbol. Clearly? Idea is clear, right? Then time to measure the plane angle. We are using degrees, minutes and seconds. Plane angle. Plane angle. Number 3, write down third one, write down third one. Third one is, third one, write down third one. Third one is what? Volume. Yeah, what is the SI unit to measure the volume? Volume means length into width into height, meters into meters into meters, meter cube. That is the SI unit to measure the volume. But especially when we are measuring liquid volumes, we are using liters, milliliters, right, to measure the volume. Write down liters. Liters. Third one is volume. To measure the volume, we are using the liter. Liter. Other unit is liter. The symbol is simple L. The symbol is simple L. The symbol is simple L. Now remember now this idea also. Okay, right. Okay, next one. Fourth one. Fourth one, then mass. To measure the mass, we are using kilograms. But remember, to measure the mass, we can use tons, metric tons, tons. 1 ton is 1000 kilograms. Tons. To measure the mass, we are using tons. Simple T. To measure the mass, we are using tons. Tons. Symbol is simple T. Tons. Right? Next one. Next one. Next one is energy. The SI unit to measure the energy is joules. But in addition to joules, we are using calories, electron volt to measure the energy. Other units to measure the energy is calories and electron volt. Right? Electron volt. Electron volt. Electron volt. Right? Energy means write down electron volt, fifth one. To measure the energy, the other units that we use to measure the energy is electron volt. Electron volt. Volt, symbol is simply capital V. Simply capital V. Simply capital V. Sixth one is, write down, sixth one is to measure the atomic mass. To measure the mass, we are using kilograms only, but other units to measure the atomic mass is write down atomic mass unit. Atomic mass unit. Atomic mass, the symbol is atomic mass. To measure the atomic mass. Atomic mass. So we are using the other unit as atomic mass unit. In chemistry, you might have learned atomic mass unit. Atomic mass unit. The symbol is simple U something. Right? The last one. Last one is length. To measure the length, we can use the meters. There are other units to measure the length. Length we can use to measure the other units to measure the length. The other units to measure the length is what? Parsec. P-A-R-S-E-C. Parsec. P-C. Parsec. P-A-R-S-E-C. Right? P-C. P-C. Parsec. Right? Then all the ideas are finished. All the stories are finished. We completed discussing all the tables. Right? Okay. Time is exactly 8:26. 8:26. I think now we can talk about. Just roughly remember these ideas. And we are doing some questions. Today we are doing some questions, right? I think units and dimensions. Units we are complete theories. Okay. Today we are complete theories. I think, and we are planning to start dimensions idea today, right? After the break we are starting that. We are taking a break and then we are starting important points regarding units, and then we are starting prefixes. Once we finish prefixes, today we are starting dimensions. So we can give a small start today for dimensions. I think all theory points are very clear, right? We are doing a separate, there are separate exercises we are doing to thorough more about the unit system, to conversions, how to convert seconds into minutes, hours into years. We are doing some different exercises also. Okay. And once this unit 1 is completed, immediately we are starting our past paper discussion. Right? Normally we have a very big past paper plan. After completion of every unit, right? We are giving set of past papers, all the past papers, MCQ structured essays, and you should do those past papers. You should try those past papers by yourself all first, right? Then I will do the entire discussion, right? Every unit we are doing that, even mechanics, every unit, and also once every unit is completed, we are keeping a kind of unit exam, right? To evaluate yourself, because mostly students who are doing online classes, right? It's very difficult to focus, no? It's very difficult to concentrate. That is the only challenge for them, right? They have enough time comparing with other students. They are going schools, other students they are going schools, but students who are doing online classes, especially most of them, they are doing private T levels, some of them going schools, but still students who are doing the classes via online, they have sufficient time to do their work. But the problem is what? Very difficult to focus, no? Sometimes when they don't expose to the school environment, sometimes when they don't go for a physical class, sometimes what happens is they can't evaluate themselves. In that case, what we do, we are keeping continuous exams to evaluate yourself. After completion of every unit, we are keeping unit exams, and also once in 2 or once in 3 months, we are conducting a big exam series, and the top students, the top mark students, we are giving small gift prizes to encourage them. Right, that story is also happening, right? It's a very big plan. We just started. First week we didn't do anything, just the introduction. Last week we done something, we learned something. But today I think we learn more than that. This is how the way that we are doing our classes, right? If you have a very good self-discipline, and if you have a dedicated, if you have really dedicated, and if you have a vision, right? If you're ready to sacrifice, and if you're ready to work unconditionally, remember, getting A for the subjects are not difficult actually, right? Very challenging only, that's true, but getting A for the subjects are not difficult actually, right? In this aerial journey, sometimes in the beginning you feel like everything is easy, but you will understand with the time, sometimes there are so many struggles you have to do. You might face many struggles, but if you have a very 100% commitment, and if you are working unconditionally, definitely you can get A pass, right? That's what I want to tell you. Possible, it's possible. But from the beginning to the last moment, you should have a proper plan. You should come for the classes. If it is live classes, you should join live classes. You should not watch recordings. Even you are getting recording access, you should never. You should keep a goal, right? Sir, I started my earlier journey from this month. I'll try my maximum, always till the last day of the classes in my A-level journey. I will join live and I will cover it. I never try to watch the recordings. That is your ultimate goal. Keep a motto like that. What happens is when the recordings are all ordered, it's a different story. So therefore, don't order the recordings, right? Keep a motive, right? I will learn everything properly, right? Every class when I join, right? I don't mind about when the class is going to finish. Till the last moment, I stay focused. Each and every point my sir explains, every point I just properly, I listen properly. Every point, every important point I write on my notebook. Sometimes some theory points are sir don't provide as a note. In that case also, if I feel something is very important to me, immediately I take a piece of paper and I mark, I note those notes. Right, I will join live. All the exams I will participate. I never skip any exam. Even my mark is 100 too. Even my mark is 0, so I don't mind. Each and every exam sir conduct, I'm going to write. I don't mind about the marks. I want to do the paper and I want to evaluate myself. I want to learn from my mistakes. If you have that type of motive, right? If you plan everything proper daily after class finishes, I will read to every question sir discuss in the class. Right, every week after class finishes, I will prepare my own short note point book, short note point book. Always I figure out what are the mistakes I made in an exam, how to improve my time, what are my problems. Everything I evaluate and I improve myself day by day. I don't expect sudden growth, but definitely I will improve day by day, and my target is not to get good marks in your papers. My ultimate goal is I'm working for the A-level exam. My target is I want to get A plus for my A-level physics paper. That's how you should think, right? And then the story is possible, simple, right? Okay, time is 8:32. We'll take a 15-minute break and we'll come to the story again. Time is 8:32. We'll come at again 8:47. Take your break and drink something, eat something, and better if you can have some foods and eat something and come at 8:47. Come at 8:47. Come at 8:47. Right, okay. So then time is 8:45. So we are doing the class till 10 o'clock maximum. Till 10 o'clock maximum we are in the class. Right? Okay. Right, okay. Okay. Right, okay. All right. Right. Then take the tutor and we'll go to the next theory. Next theory idea. Take your tutor and we'll go to the next theory idea. Now, last 1 hour maximum. Last 1 hour maximum. Right. We have to complete lots of things. Right. Stay focused and learn. Stay focused and learn. Right. Okay. Then, right. Okay. Now, facts to be considered when using units. Go to the page number, the tute page number. In the tute, go to the page number. Page number 6, page number 6. Facts to be considered when using units. Number 1 is only the appropriate SI units along with their multiple or submultiple should be used to measure a particular physical quantity. I will explain what is multiple and submultiple in a while because that section comes under prefix. After writing these important points, we are starting prefixes. That is very important theory part. Right, first point they are telling only the appropriate SI unit along with their multiples or submultiples should be used to measure a particular physical quantity. Right, that means this idea, right? This idea. Now let's say you want to measure a mass. Then we know the SI to measure the mass is kilogram. To measure the mass, you can't use meters, right? If you have a sample of, let's say, sugar, you have a sugar bag, and you want to measure the mass of the sugar. Then you can use the SI unit to measure the mass is kilogram. You can use kilograms to measure the sugar mass. But you can't use meters to measure sugar mass, right? That's what they are saying in that first point. Always use the correct unit system to measure the physical quantity. That idea. First point idea. First point story. Look here. If you are measuring the mass, for example, you want to use kilograms. Simple K, simple G. If someone is using meters to measure the mass, that's wrong, right? You can't use meters to measure the mass. Got it? Always use the exact correct unit system to measure that relevant physical quantity. Okay? If you are measuring the time, you can't use meters to measure the time, right? If you measure the time, you can use seconds, hours, minutes, whatever. That's the first point. What you can do, this idea you can write below the given space. I have given small space to write this idea. Mass means use kilograms. You can't use meters to measure the mass. That idea. Point number 2. Point number 2. The same symbol must be used for a unit in both its singular and plural forms. That is important. Highlight. Same symbol, singular, plural forms. Most of you do this mistake, especially when you are doing these essay papers. I have seen that most of the students, they are doing this mistake. For an example, let's say you are measuring a length. Let's say you are measuring a length, let's say the length of a rod. The next point, second point, look here. Now you are measuring a length of a rod. Think like that, there's a rod. There's a rod, iron rod, or metal rod, whatever. Right? You are going to measure the length of this rod. Length is simple L. Simple L. Length is simple L. You are going to measure the length of the rod. When measuring length, let's say the length is 1 meter. Length is 1 meter. Length is 1 meter. 1 meters. 1 meters. That is 1 meter. M-E-T-R-E. If it is 1 meter, you guys tell 1 meter. Let's say now the length is 5 meters. See, when you are telling 1, length of that rod is 1, if you are using the unit 1 meter. But when the unit is 5, if the magnitude of the length is 5 meters, we are saying like that, no. There is no issue with that. You can tell 10 meters, 20 meters, you can use the plural form when measuring a length. If you are measuring a mass, the magnitude of the mass is 1, you can tell 1 kilogram. Let's say you are taking the unit as kilogram, magnitude of the mass is 5 kilograms. We are when talking, we are using singular plural forms. But the problem is, remember, that is okay. If I am measuring length is 1, means 1 meter. In case if the length of the rod is 5 meters, that's okay. 5 meters. But remember, when you are writing in the unit system, what some people they are doing is, they are writing is 1 meter as 1 meter, okay. 1 meter, okay. But some people when writing 5 meters, they are writing 5 meters. It's wrong. Do you understand? Some people use 5 meters, simple limits. When talking, you can use 1 meter, 5 meters, you can write. But if you are writing the magnitude of the physical quantity with their SI unit to show the plural 5 meters, one can't use simple list after simple lim. Do you understand? You can't use simple list after simple lim. Then it gives a different meaning. This gives millisecond something. You can't use like that. Even if you want to represent 5 meters, then also you want to use 5 simple lim only, right? If you want to represent 5 meters, even though it's a plural value, you want to use only 5 meters simple lim only. You can't use 5 meters simple lim, you can't use. You can't use. Do you understand this idea? 5 meters, 10 meters, whatever, 100 meters. If you're writing in terms of the symbols, 5 simple meter, right? And let's say you are measuring a mass in kilograms, right? Let's say magnitude of the mass is 1, then 1 kilogram, right? 1 kilogram. So we write down, right, mass 1 kilogram. If you convert it into the SI unit symbols, 1 kilogram, if you convert to the symbols, that is what? 1 simple K, simple kilogram. But the problem is when in the plural form, let's say the mass is 5 kilograms. Some people write down, if I ask them to write the magnitude of the mass in terms of the unit, 5 kilograms, some people write down it as 5 kilograms, kgs. Remember, you can't write like this, even it's plural. When you're writing the unit, only you want to mention 5 kg only, 5 kilogram, 5 kg only. 5 kg only. Do you understand? 5 kg only. You can't use, even the value is a plural value, 5 kilograms. When you are converting, when you're writing the SI unit, when you're writing the unit, when you're writing the magnitude of the unit, you want to mention only kilogram only. You can't go beyond that. Only mention kilogram. This idea. You can't use S meters, kilograms. You can't use that S term story. Right? Time also same. Time also 1 second. You can use 1 simple list. Even you are measuring 5 seconds. When we are talking, when you are pronouncing, when we are talking, we tell 5 seconds, 10 seconds. But if you are writing the magnitude in terms of the units, you want to mention 5 second S only. You understand? Time. Right? Time. If you are measuring in seconds, time. 1 second The value is a singular value, it's okay. Everyone write down 1 second, simple is. But the problem is, when you're writing 4 seconds with their units, 4 seconds, when you're pronunciating, when you're talking, we say 4 seconds. But when writing its unit, some people write down 4 seconds. It's wrong. Only 4 seconds. Only 4 second, idea clear. That point also clear. This point also clear. Understood. Now these are very case sensitive subject. Next story, write down number 3. Third point, write down. Third point. Blue color pen, normal pen, write down. Third point, the given space. Third point. Now please write down these examples also under the point number 2. In third point, write down third point. The symbol of units should always be written after the numerical value, comma. And these and there must be a single space between. 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 The value and the unit symbol. The value and the unit symbol. Right, there must be a single space between the value and the unit symbol. Now let's say when you are measuring a length, let's say length of that rod is 5 meters. Right, remember between the value and the unit you must give a small gap. When you're writing 5 meters, there must be a small gap between the value and the symbol. Some people, what they do, when writing 5 meters, they write down 5, they write the meters also closer to the value. This is wrong. When writing the value and the symbol, you should maintain a kind of gap between the value and the unit. Right? But you don't mention a huge gap. Don't write down 5 meter means don't write down 5 here and meter there. You should maintain a kind of considerable gap between 5 and meter. That is the idea. It's not difficult. Next story. Point number 4 idea. Write down that is given me. When writing units with prefixes, we will talk about prefixes in a while. When writing the units with prefixes, a dot should not be placed between the prefix and the unit symbol. Right? You will understand what is a prefix. Don't worry. Normally meters, we all know that. Even though SI to measure the meter, SI to measure the distance is meter. We are using kilometers, right? Centimeter, millimeter. This kilo, centi, milli, they are what we call as prefixes. We will learn in a while what is prefixes, don't worry. Now, especially when you are using a prefix, that's roughly put in your mind. Let's say kilometer. When you are writing a prefix, kilometer, kilo is a prefix. When writing units with prefixes, a dot should not be placed between the prefix and the unit symbol. Right? Let's say now kilometer. Meter is the SI unit to measure the distance. When you are using a prefix called kilo, simple K, kilo. Right? Remember this simple K is the prefix. You will learn in a while. You haven't learned what is prefix yet, but you will learn in a while. Just think this K as a prefix, that's it. Just put in your mind this K as a prefix. Put in your mind this K as a prefix. It's a prefix. Right? You should not keep a dot in between this prefix and the unit meter. You can't keep a dot between them. Right? When you're writing a unit with its prefix, there should no any gap between the prefix and the unit. You're writing the kilometers, you write down simple K nearby simple lim. Do you understand? This is correct and this is wrong. You can't keep a dot between the prefix and the unit value, unit. Don't worry, you will understand what is prefix in a while. After discussing the last point, I will teach you what is prefix. It's a big story. That story is important not only unit 1, unit 2 to unit 11. Most of the sections, this prefix idea is very, very important. Right, then point number 5, write down. Point number 5. Please write down these stories also in the given space. Write down these things in the given space. Point number 5, write down. 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 Point number 5. Point number 5. Okay. Right. Write down. A prefix should be used. Don't worry, I will explain everything properly. A prefix should be used with a symbol. A prefix should be used with a symbol when the numerical value of the measurement, when the numerical value of the measurement lies outside the preferred range lies outside the preferred range of 0.1 to 0.1 and 1000. 0.1 and 1000, I will explain that idea after explaining prefixes, okay? Point number 6, okay? Point number 6, don't worry. Point number 5 and once again point number 4, I will explain after we learn the prefixes. Then only you understand more. Point number 6, write down. I have given, when writing compound units, a center dot should be used to indicate the product of two units. Right, when writing compound units, a center dot should be used to indicate the product of two units. While omitting the dot is not strictly incorrect, it is only acceptable if there is no risk of confusion with another unit symbol. In such cases, the units must be separated by a thin space. Look here. Now, Newton meter. Point number 6. Point number 6, now they are telling Newton meter. Right, to separate, you can write down Newton and you can keep a very small space between Newton meter. You can write on Newton and small space then meter. They are telling when you are writing compound units, you can use a dot, no issue. When you are writing a compound unit, one option is this capital N and simple M, you want to maintain a small gap, not huge gap. That is one way. If not, they are telling when you're writing a compound unit, you can use Newton and a dot and simple M meter. Right? Now both are correct. Both are correct. Especially let's say now if there is a unit called kg ms minus 1. I told you, last class I told you, you want to maintain a considerable gap between base units kg. And simple M, a small gap between base units kg, a small gap meter, a small gap second minus 1. If not, one can write down kg dot meter is simple M dot second is s minus 1. But mostly we don't keep dots and we don't write the units generally. Generally what we do, when in the practice what we are doing, we are maintaining a small gap between the base units and we are writing the units. That's the normal practice. But they are telling even if you feel like it's confusing, you can keep a dot between base units. Okay, both are correct. Both the stories are correct. This idea, okay, clear. This idea also clear. The last point, I will explain point number 4 and point number 5 once again, don't worry. Point number 6 idea is clear. We can use dots also to separate the compound units. To separate the base units, we can use a dot. That is also clear. Last point. Point number 7, write down. Point number 7, write down. Point number 7, write down. When writing a compound unit, when writing a compound unit, when writing a compound unit involving division, comma, involving division, comma, involving division, comma, use a solidus, solidus, use a solidus. Inside the bracket write down forward slash, comma, inside the bracket write down forward slash, comma, this symbol, close the bracket, forward slash, comma, the symbol, close the bracket. Or a horizontal line, or a horizontal line, full stop, full stop, full stop, full stop, full stop, right? If I repeat once again, point number 7, when writing a compound unit involving division, comma, use the solidus, inside the bracket forward slash, comma, this symbol, close the bracket, or a horizontal line. Don't worry, I will explain the idea, don't worry. Continue, okay. Alternatively, the denominator may be expressed. Alternatively, the denominator may be expressed. Alternatively, the denominator may be expressed using negative component exponents. Using negative exponents. Right? Okay. Now, look here. The best physical quantity to explain this point is, let's take it as velocity or speed. Speed. So we can remember speed. Speed, we all know that is distance over time. Speed means we all know that the last point, speed is, we can remember distance over time. Distance over time. Distance over time. Then what is the SI units of distance? It is measured in meters, simple lim. Distance measured in meters, simple lim. What is the SI units to measure the time? Seconds, simple s. Simple s. So you can simple s. You can represent the units of speed in 3 different ways. If you are using a slash, you can represent the units of speed going to be meter slash second. No issue. In the exams, they ask you to write the units of speed meter slash second. This is what we call as solidus, no? If not, what you can do, some people can keep the units of speed in this way by using that horizontal line. Units of speed is equal to meter over second. Meter, horizontal line is over second. You can keep the unit also this way also. No issue. Both the ways are okay. But as a practice, generally what we do, we bring this denominator also to the numerator. Do you understand? What is the power of s, which is at the denominator? It is 1. If you bring s to the power 1 to the numerator, it becomes s to the power minus 1. The third way is by using the negative exponent. The third way is what? Meters s to the power minus 1. All 3 ways are correct, but very frequently, mostly we are using this way. All the 3 methods are okay, but mostly we are using this way. Clear? Right, point number, I think you might have a problem with point number 5 and 4. Don't worry, now main topic, the last main topic, prefixes. Then unit section is completely, we discussed every point properly. Each and every theory point I explained properly. Then we can start dimensions, right? The prefixes idea. write down the stories also. If you haven't, if there's a space. In that given space, write down the stories also. Right? Okay. Done. The last theory point. Now this is sometimes don't come to a conclusion about the subject based on last day what we discussed and today what we are learning. Right? The real physics is really interesting. Mostly the question based lesson subject. Right? Generally in physics you don't have to write what I say. Generally when I explain a concept, then you want to think from that concept and you should do the questions. Right? Very beautiful lesson. But first lesson is really it's kind of learn by heart lesson. That's the problem. The real lesson in mechanics is starting from mechanics. The real lesson in physics is starting from mechanics. Unit 2. Okay. Right. Okay. Prefixes. The main topic. Main topic prefixes. Main topic prefixes. Main topic prefixes. Page number 8. Page number 8. Prefixes. A very important section. Very important section. Not only important to do questions in unit 1 but also unit 2 to unit 11. Every chapter this prefix knowledge is very important. Very important. Okay. Quickly write down these stories. Quickly write down these stories. Write down the stories. These stories write down. This story write down. This to write down. Right? Okay. Right, okay. All right. Okay. Right, okay. All right. Nice, no? Okay. Now go to the page number that you go to the page number 8. Then I have mentioned SI prefix. An SI prefix is a name or symbol placed before a unit of measure to indicate a multiple or submultiple of that unit. The next line write down. The next line write down. Each different color pen write down. Each prefix has a unique symbol. Different color pen write down. Each prefix has a unique symbol and represents a specific power of 10. Each prefix has a unique symbol and represents a specific power of 10. This idea. Prefix, SI prefix. SI prefix. SI prefix. Main topic SI prefix. SI prefix. SI prefix. So what is an SI prefix? What is SI prefix? Right? I mentioned there SI prefix means what? A name or symbol. A symbol placed before a unit of measure to indicate a multiple or submultiple of the unit. It's a symbol that we are using in front of a unit. What are the units? Tell me. Simple meters is a unit. Right? Then we can do second. Simple is second is a unit. In front of the units we are using a symbol. Look here. Meters is a unit. Seconds is a unit, no? In front of the unit we are using a symbol. In front of the units we are using a symbol, but that symbol has a specific unique symbol. It's a unique symbol and it has a specific value in the power of 10. the power of 10. In the power of 10. Right? In the power of 10. Look here. What is prefix? Prefix means a symbol which is in front of the unit. Which is in front of the unit. Has a specific value in the power of 10. 10 to the power 1, 10 to the power 2, 10 to the power 3. We don't know what is the power. Those are what we call as prefixes. Those are what we call as prefixes. Okay. Understood, somewhat idea okay. But still I don't understand why they are using such prefixes in front of the unit. Still I don't understand. But the idea is clear. In front of the units we are using a kind of symbol. Those symbols has a value in the power of 10. That is clear. Prefix. Right? Prefix. Okay. Prefix. Remember, prefixes we can divide into two categories. Prefix we can divide into two categories. One is multiples. That is also a kind of prefix. Other one is submultiple. Prefix we can categorize into two categories. One is multiple and other one is submultiples. Right? Prefixes. Two categories. Multiples. Other one is submultiples. What are multiples and what are submultiples? Submultiples. Submultiples. Right? Okay, clear. Multiples, submultiples. So what is multiple? Still I don't understand what's a prefix. Now you are telling we can break prefixes into two categories, multiples, submultiples. What are those? I don't understand. Right? Now we know that there are values. Right? Let's say now you want to measure a length. You are measuring a length, you can tell you are measuring a length of a road. Right, let's say now you are in a country like a very huge country. If it is Sri Lanka, we know the north to the south, the total maximum distance is about around 700 kilometers. So therefore our country is not a big country. Let's say now if you are in China, let's say if you are in Russia, wherever US, you are measuring a length of a road. Right, the problem is, if you are measuring the length in SI unit system, that is meters, you are measuring the length of the road in SI unit meters. Right, then you are getting a value, the total length of that road in meters is going to be how much? In meters how much? Let's say, that is, right, for an example, in meters, if you measure the length of the road in meters, you are getting very huge value. You are getting very huge. For example, I am telling you, in meters, right? Then can you read this value? If it is 50 meter, the value is this one 500 meter, 5000 meter. Now, when the value is getting larger, it's a bit difficult to read 50,000 meter. Now, if the value is exceeding beyond this value, now 500,000 meter. Thereafter, it's a bit difficult to read. It's difficult to read the value. It's a problem. Right? That means when we are using SI units to measure the physical quantities, when the magnitude is exceeding, when the magnitude of the physical quantity becomes extremely large values, expressing that magnitude in SI unit only meters, only seconds, it's a problem. Difficult to read, can't read actually. Can you read this value? Can someone read this value exactly? We can't read, no? We can't read. Right? Not only when you are measuring very huge distances, very huge magnitudes of the physical quantity, again you will struggle when you are measuring a physical quantity, extremely small value. Let's say you want to measure the distance between two atoms in a substance. When you go to the microscopic level, if you want to measure the distance between two atoms in that sample, we all know that the gap between the distance between the two atoms. If not, you want to measure the radius of atom. So we can imagine radius of an atom is extremely small value. Radius of an atom is also a length, right? If you're using the SI unit to measure the radius of an atom, you have to use meters. But the problem is you can measure the radius of the atom in meters, no issue. The problem is when you're writing the radius of an atom. Is the radius of an atom? The radius of an atom going to be its very small value, right? Okay, previously explained that when you are measuring a length, the length becomes generally, what is the SI unit to measure length? Meters, right? Let's say if you are measuring a very huge length in meters, the problem is we can't read and we can't write, we can't record easily. If you miss a single zero, the entire value is wrong, right? This happens not only when measuring huge values in SI units. This issue happens when measuring very small units also, very small measurements. This issue happens when you're measuring very small measurements by using SI units. For example, if you're measuring the radius of an atom, let's say for example, radius of the atom is let's say 0. For example, 0, 0, 0, 0. 125 meter for an example. Now, can someone read this value? And do you think is it easy to record this value? Is it easy to write this value? Can we communicate easily? Now suddenly I'm asking what is the radius of an atom? If not, just think what is the mass of an atom? If you are using the SI units and if you are expressing, it's very difficult. This problem arises especially when we are using the SI unit system and when you are measuring extremely huge magnitudes and when you are measuring extremely small magnitudes, this problem arises. That's why to overcome this issue only, they introduce prefixes. Prefixes we can talk about two different categories. One is multiples, other one is submultiples. So when we are using multiples, especially if you are measuring a very huge value from SI unit, we can use multiples and we can small the size. No, look here, I will tell you. Under multiples, inside the bracket I mentioned large scale. Multiples are used for quantities larger than the base unit. Inside the bracket 10 to the power 1 into 10 to the power 24. Look here, for an example, there is a multiple. Okay, first of all, I will tell you the multiples of prefixes and I will give the set of multiples and their values. Then I will come back to the story. Okay, right? Then we'll go back to theory. Right, first of all, now very clear, why are we using prefixes? When the magnitudes become extremely large or small, to sort out that issue only, we are using the prefixes. Every prefix has a unique symbol. We are using that prefix in front of the unit. Each prefix has a value of 10 to the power something. That idea clear? Then I will tell you what are the prefixes comes under multiples, what are the prefixes come under submultiples. Then I will come down this idea once again. Right? First of all, we'll write the prefixes come under multiples. Write down in the given tables. Write down prefixes, prefix, symbol, factor, numerical value. Right? Okay, number 1, write down. If I come to the table also, prefix, symbol, factor. Prefix, then symbol, right? Okay, I erase this value. Prefix, and symbol. Prefix, symbol, then value. Factor numerical value. Factor then the numerical value. Numerical value. First of all, we'll complete the multiples. Come under prefixes. Numerical values. Numerical values. Values. Right, okay. Right. Number one, write down. Number one, write down. First one, write down. First one, exa. Right, the prefix is exa. Capital E, XA, exa. Exa. The symbol of this prefix is capital E. Capital E symbol is capital E, exa, capital E. Right, factor is, I told you, each prefix has a symbol. Each symbol has a significant value. Exa is the prefix. Its symbol is capital E. This capital E has a unique value in the power of 10. The power is, remember, 10 to the power 18. Exa, capital E means, remember, the power is 10 to the power 18. 10 to the power 18. The value is 10 to the power 18. Right, okay, the guide, don't worry. Okay, the one of the prefix is exa, the symbol is capital E, its value, the symbol has a unique value in the power of 10. This one's value is 10 to the power 18. Right? If you write this 10 to the power 18 as a numerical format, how would you write down? 18 zeros. Start writing. 18 zeros. 1, 2, 3, 4, 5, 6, 9, 12, 15, and then 18. Right? Okay. So for an example, I will tell you, for an example, how we are using prefixes, especially multiples, and how we are going to make larger magnitudes, how we are going to express larger magnitudes easy way. Let's say you are measuring a distance. Distance, for example, length or distance. For example, length. As explained earlier, length is how much? Length is, for example, length equals, for example, write down, for example, 18 zeros. We can't easily communicate, no? When someone is asking you what is the length of that object or whatever, you can't tell 18 zeros. You can't tell like that. 3, 6, 9, 12, and 15, 18 meters. You can't tell that. We can't read. Can someone read this value? We can't read, no. But just now we learned that if there are only 18 zeros, this value is equal to what exactly? One can write down. This is what 10 to the power. If you convert into power format, it's 10 to the power 18 meters, right? Then one can write down 10 to the power 18 means this is a prefix, multiple. 10 to the power 18 is a prefix, it's a multiple, that is exa. What can write down? This is 1 into 10 to the power 18 meters. That is what? That is equal to 10 to the power 18 means what? 10 to the power 18 means you can remember that is exa, capital E. Capital E, you can write down the length of that substance or whatever is 1 hexameter. 1 hexameter. You understand? Right, if there is a very huge value, if you write only in terms of SI unit meter, you can't even read this measurement. But if you use the prefixes, this time I'm using exa, I can tell easily the length of this 1 hexameter. So what is a prefix? We are using a symbol in front of the SI unit. That symbol has a unique value in the form of something. That prefix has a unique value in the form of something. That idea clearly. Then there are other multiples, other prefixes. Exa, peta. Peta. not that peta, it's peta. Capital P, simple T, peta. Symbol is capital P. Capital P, symbol capital P, write down, symbol capital P. The factor, the value is 10 to the power 15. 10 to the power 15, the value. If you convert into numerical value, how much? Numerical value is 15 zeros. 15 zeros. Right? 3, 6, 9, 12, 50. Third multiple is hexadone, petadone. Next one is tera. You all know that, especially when you are dealing with these computer storage things. I have 1 TB hard disk. I have 10 TB hard disk. Right? Then RAM capacity is GB, gigabytes, TB, terabytes, tera. Right? If the byte represents a kind of storage, no? That bytes measures a kind of storage, no? Then we can use to show that huge number of bytes, terabytes. Okay? 1 TB. Tera. Tera. Tera means what? Capital T. Symbol is capital T. Symbol is capital T. The value assigned for the tera, capital T, is, remember, 10 to the power 12. Tera means what? 10 to the power 12. 10 to the power 12. The numerical value, write down. The numerical value is going to be 12 zeros. 3, 6, 9, 12. Then fourth one, gigabytes, GBs. GB, gigabytes, GB. The data, I have a set of data in my phone, 20 GB, right? Data, gigabytes, giga, capital G, giga. Giga, the symbol is capital G, the value is 10 to the power 9. Capital G, the value is 10 to the power 9. Right, then 9 zeros. 9 zeros, 1, 3, 6, 9. Then fifth one is mega. Giga means 10 to the power 9. The next one prefix, next multiple is giga. Sorry, mega. MB. 20 MBs in data. I have 20 MB data remaining. Mega. Mega means capital M. Symbol is capital M. Symbol capital M. Symbol capital M. The value is, remember, mega means 10 to the power 6. 10 to the power 6. Numerical value is how much? Numerical value is going to be, there are 6 zeros. 1, 2, 3. Okay? 4, 5, 6. Then what? Sixth one, hexa, peta, tera, giga, mega. Next one is kilo, hecto, deca. Kilo, right? Kilo, 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 right? Kilo. Next one is kilo. Symbol is right, capital K. Symbol is capital K. The value is 10 to the power 3. Numerical value is how much? 1000. 10 to the power 3. 10 to the power 3 means how much? 1000. Then next one is hecto. That is hecto. Last two. 7 is hecto. A hecto symbol is simple H. The value is, remember, 10 to the power 2. Hecto value is 10 to the power 2. Then it's 100. The numerical value is how much? 100. 100. The last one is, remember, deca. Symbol is simple DA. The last one is deca. The last one is deca. Deca symbol is simply. Deca means simply. The value is 10. The value is 10 to the power 1. The value is numerical value is 10 again. This is the idea. This is the prefixes we are using for multiples. You understand? You should be able to remember now. You should remember if I ask you exa means for the numerical value, what is the symbol? Exa means capital E, peta means capital P, tera means capital T, giga means capital G, mega means capital N, kilo capital K, hecto simple H, deca simple D, and you should remember their numerical value also. Do you understand? Now quickly convert. Now start converting. Okay, we'll complete. This is the prefixes comes under multiples. You want to understand all these values are above 1. No? All these values are above 1. Right? All the values are above 1. Therefore, these all we are calling as multiples. And you notice especially right above this capital K, all the symbols are in capital letters, and their values are increasing by the power 3. 10 to the power 3, 10 to the power 6, 10 to the power 9, 10 to the power 12, 10 to the power 50, 10 to the power 8. But especially when you consider hecto and deca, the values are 10 to the power 2 and 10 to the power 1. Right? That is somewhat special idea. Symbols are simple. Right? Above, including kilo and above the kilo, all the symbols are in capital letters. But hecto and deca, the symbol is in simple letters. Above capital K and K, right? All the powers are increasing by the value of 3, 10 to the power 3, 10 to the power 6, 10 to the power 9, 10 to the power 12. But these two values are 10 to the power 1 and 10 to the power 2. These ideas. Right, okay? Then I will explain what are the stories comes under submultiples. Then I will give you some kind of oral idea, and then we'll go back to some questions. We'll convert prefixes, suffixes into SI unit system. I will tell you some questions. Time is almost 9:40, right? We have a maximum 20 minutes to be done, right? Today we are doing the class continuously. We want to complete this section. Right? The last few stories. Now we'll talk about submultiples. Submultiples means they mentioned submultiples are used for quantities smaller than the base unit. Right? The base unit is, let's say, if you're measuring a length, meter. Right? If you're measuring a length, meter. Right? Remember, multiples are greater than the base unit. Even the smallest multiple is 1. Right? Remember, even the smallest multiple is 1. That is also greater than the base unit 1 meter above. Submultiples are smaller than the base unit. So if you write the submultiples now, after writing multiples, just write the submultiples. Submultiple table. If you draw the submultiple table, just start drawing. Submultiple table now. 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 Right? Again, prefix, symbol, factor, numerical value. Prefix, symbol, factor, numerical value. Now we are talking about submultiples. 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 Prefix, symbol, and then the factor, the numerical value. Factor, then the numerical value, then the numerical value. Numerical value. Right? Numerical value. Right? Okay. Then from the story we can complete. Okay. Remember deci. Number 1 is deci. The first submultiple is deci. Number 1 is deci. The symbol is, remember, deci symbol is, remember, that is deci. Centimilli. Deci simple D. Deci symbol is simple D. Deci symbol is simple D. Right? The values, remember, 10 to the power minus 1. 10 to the power minus 1. If you write the numerical value 0.1, the numerical value is how much? 0.1. 0.1. Second one is centi. Centi. Symbol is simple c. Centi means simple c. 10 to the power minus 2 value. The centimeters, remember, value is 10 to the power minus 2. Numerical value is how much? 0.01. 0.01. Third one is deci, centi, milli. 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 Simple mi, double li, milli. The symbol is simple lim. Symbol is simple m. Milli means simple lim. Okay, simple, not meters. Yeah, meters also, the unit meters also we use same simple lim to represent this prefix. Submultiple milli also we are using simple lim. Simple lim. Mega means we are using capital lim for the milli. Mega is a multiple, the symbol is capital lim. Milli is a submultiple, the unit is simple lim. The symbol is simple lim. The value of simple lim milli means, remember, 10 to the power minus 3. The numerical value is how much? 0.001. 0.001. Last few stories, then theory finished. Unit section is entirely finished. Unit section is entirely finished. Last few stories. Fourth one. The next day we can do huge number of questions. We can start dimensions. Today I plan to start dimensions. But it's okay. It's okay, right? We can start dimensions in the next day. And we can do huge number of cute questions next day. Okay. Then micro. Micro, remember micro is also a submultiple micro. The symbol is a Greek letter. The Greek letter, that is micro means mu, no? It's mu, not simple lim, not capital lim. It's a Greek letter mu. It's a Greek letter mu. The value is, remember, 10 to the power minus 6. Right? The numerical value is how much? It's going to be 0.000000001. Okay. Then nano. Simple in nano. Symbol is simple in. Symbol is simple in. Nano. Simple in. The numerical value is how much? 10 to the power minus 9. 10 to the power minus 9. The numerical value is how much? 0.00000000001. 3, 6, 9. 9 zeros. Sixth one is, remember, sixth one is nano pico. Pico. Symbol is simple p. Simple p. The value is, remember, 10 to the power minus 12. But mostly in our syllabus questions, they give the values in centi, milli, micro, nano. Generally, they don't go beyond pico stories. In our, when you go and check the past papers also, right, most of the questions are in centi, milli, micro, nano stories. Especially when it comes to the multiples, mostly they will give in terms of kilo, mega, giga. Rarely only they talk about tera. Peta, exa, normally we don't use, and past paper questions also never came from these ideas generally. Okay, but better you must remember these values. You must remember the symbol and the value, right? Then I will tell you how they can ask questions. We'll arrange a kind of past paper discussion also, right? Then you will understand how these things we learned in our theory class for last 2 days, how they're gonna apply for a paper, how past papers came from this section. Don't worry, we'll do. Right, we'll come to the theory today. The pico means what? Pico means symbol is a simple p. The value is 10 to the power minus 12. Minus 12. The numerical value is how much? 0.00. 0.00001. Then last one is femto and natto. There are two last one. Femto. Seventh one is femto. Femto. Right, femto. Okay, femto. Okay, femto. The last one is femto, and then atto. Femto, then atto. Right. Femto, Symbol is simple if. Atom is simply. Symbol is simple if. Value is 10 to the power minus 15. The value is how much? 0. The value is, remember, 0.123 9 12 15. Last one is atto, then finished. Atto. Atto, symbol is simply. Symbol is simply. Symbol is simply. The value is 10 to the power minus 18. 10 to the power minus 18, the value 18. The numerical values, remember, 0.0336 9 12 15 18. That's it. But you must remember what is multiple, submultiple. We realize, remember, multiples are above. The values of multiples are above 1. Right? That even the decaris also has a value 10 to the power 1, 10. But submultiples, they are having a value less than 1. 0.1, 0.01, 0.001. Right? That idea. That idea you must remember. Hereafter, prefixes are two categories, multiples and submultiples. Especially multiples are using when the magnitude of the quantity is extremely large value. Submultiples are we are using when the magnitude of the quantity is extremely small value. Why are we using multiple submultiples? If the value is becoming extremely large or small, it's very difficult to express, difficult to pronounce, difficult to write, note, record. In the cases, right, if you can use multiples and submultiples, you can easily express. Right? You can easily express. For an example, rather than saying, let's say now this one. Rather than saying this one as, see, this is 1000 meter. For an example, 1000 meter. One can do 1000 meters. It's okay, 1000 meters are not big story. Therefore, anyone can do 1000 meter. But rather than saying it as 1000 meter, you can use a multiple. 1000 meter means, see, 1000 meter means one can write down. 1000 meter means 1 into, if you convert 1000 into scientific notation, if you can't remember what is science notation, in our Friday session, that basic math session, I am teaching how to do scientific notation, how to use logbook, everything I will teach you this Friday. 1000 meters, remember, if you convert to scientific notation, 1 into 10 to the power 3 meters. 1000 means, remember, 1 into 10 to the power 3 meters. Just now we learned that 10 to the power 3 means what? 10 to the power 3 is assigned to kilo, capital K. So one can write down kilo, 10 to the power 3 means what? Kilo. Rather than writing 10 to the power 3, one can replace this value 10 to the power 3 by capital K. Then one can write down 1 kilometer. When writing the prefix, there should not any gap between the prefix and the unit. There should not be any gap. 1 kilometer. What is easy? Saying 1000 meters is easier. Saying 1 kilometer is easy. Saying 1 kilometer is easy, right? It's a small value, therefore one can tell no, so 1000 meter also no, fine, we can read. But if the value becomes extremely large value, for example, let's say, see, 25 this story. Then meters. Can someone read this one? How do you read this one? 250,000 meter. So one can write down, if I convert this value into scientific notation, if you can't remember science notation, don't worry, I will teach you. 2.5 into 10 to the power 6 meters, no. 10 to the power 6 means we know that this value 10 to the power 6 means that is mega, capital M. Capital M. 10 to the power 6 means what? 10 to the power 6 means what? Mega, capital M. Then one can write down, sir, 2.5, right? 10 to the power 6 means I can write down it as mega, capital M. 10 to the power 6 means mega. If you use a prefix, mega, capital M, simply megameter, 2.5 megameter. What is easy? Rather than saying 250,000 meters, one can tell 2.5 megameter. That's how we are using prefixes. Okay, the next idea is, for an example, let's say now you are measuring a time. The time, let's say time taken is let's say now 0.000000, right, 33, okay. Then first of all, seconds, okay, seconds. Try to convert this value into scientific notation. If you convert into scientific notation, if you do it 1, 2, 3, 4, 5, 6, 7, 7, right, 1, 2, 3, 4, 5, let's say like this, 6. One can write down this as 3 into 10 to the power minus 6 seconds. 0.000003 means 3 into 10 to the power minus 6 seconds. 10 to the power minus 6 means what? 10 to the power minus 6 means we all know micro. So one can use, instead of 10 to the power minus 6, one can write down 3 into 10 to the power minus 6 means microseconds. 3 into 3 microseconds. That's how we are using these submultiples idea. Right, I think all good. Today we talked about remaining sections in derived physical quantities. Then we talked about some important points regarding the unit system. Then we talked about prefixes. Now idea is clear. You must remember these values. Exa, peta, tera, giga means if I ask you what is exa, capital E, the value is to the power 18. Tera means to the power 12. Likewise, you should be able to answer these values also. You must remember. Remember, this idea is clear. Idea is clear. One last story, then finished. Time is almost going to be 10 o'clock. One last theory part, right, then finished. One last theory part, then finished. Okay, right, okay, one last theory part. Next we can start dimensions. Now, fundamental rules of SI prefixes. The first point is I have given there. Never combine two prefixes for a single unit. Okay, always use the single prefix that represents the total power of 10. Look here. What is that point says? Right, now there is a value. Look here. There is a value like this. There's a value like this. Look here. There's a value like this one. There's a value like this. The last few points. Okay, stay focused. Okay, finished. Okay, the last few stories. Now, if you have a value, for example, if you have a value like this 0.000306, a value like this, right, meters. Okay, then you can convert it into meters. Okay, so one can write down, if you convert this into scientific notation, one can write down, remember, 1 into 10 to the power minus 9 meters. If you have a doubt regarding scientific conversions, don't worry, I will teach you in the Friday class. Some people, what is the most suitable prefix? Right, I converted this distance into scientific notation, then I'm getting 1 into 10 to the power minus 9 meters. If I ask you to use a prefix and simplify it, what is the most suitable prefix that we will use? What is the most suitable prefix that you will use? 10 to the power minus 9 means we all know that 10 to the power minus 9 means the most suitable prefix is a nano. Right? So I can use 10 to the power minus 9 means the most suitable prefix is a nano, 1 nanometer. But what some people they do, the most suitable prefix is 1 nano. 10 to the power minus 9 means nano, no? This value is nanometer. But some people, what they do, rather than writing this value as 1 nanometer, what some people are doing 10 to the power minus 9 meter means what they do, sir, all level maths we learned, 10 to the power minus 9 means 10 to the power minus 3 into 10 to the power minus 6 meters. Okay, correct. What some people do, sir, if I convert these values into prefixes, 10 to the power minus 3 means that is we know. 10 to the power minus 3 means we all know that is going to be 10 to the power minus 3 means that is going to be milli simple limb. This one is milli simple limb. 10 to the power minus 6 means we all know that's going to be micro mu. 10 to the power minus 6 means micro mu. I can write down now milli micrometer, 1 milli micrometer. Remember, this is not recommended, it's wrong. Generally, we don't use two prefixes. If we want to shorten a value, we are using only one prefix. We are taking the help of only one single prefix. We don't use two or more than two prefixes in front of a unit to simplify the value. So therefore, remember, this is wrong. The best option is writing it as 1 nanometer. It's the best option. You can write it as 1 milli micrometer. We don't use two or more than two prefixes when shortening that value. That is what I mentioned there. So write down these values in the given space there. In the given space, write down this story and write down, write down in the below space. In the below space, write down in the below space, write down, you cannot use millimicrometer. Okay, write down, you cannot use millimicrometer, full stop. You must use single correct prefix, which is nanometer. You must use single correct prefix, which is nanometer. Do you understand this idea? We don't use two or more than two prefixes in front of a unit. We are only using one prefix in front of a unit. That's the way. Second point, write down. Second point, we are almost finished. The last second point, third point, fourth point, then finished, story finished. Second point, write down. Right, today I think we are going a bit faster, I think, and manageable. Today we are doing some theories, therefore can manageable. The next day we can start dimensions, then we can finish that story also. Second point, write down. Symbols are case sensitive, full stop. Second point, symbols are case sensitive, full stop. Symbols are case sensitive, full stop. Using the wrong symbol, using the wrong symbol can change the value, of your measurement, right? The best thing is, let's say now you want to write down 1 millimeter. Let's say you want to write 1 millimeter. Right, for an example, you want to write down 1 millimeter. I want to write down 1 millimeter. 1 millimeter. Then we all know that millimeter, the prefix symbol is, what is that? Prefix symbol is 1. Milli means simple limb, no? Milli means simple limb, millimeter. Meter is the unit, millimeter. But once someone's writing, he forgot the symbol of millimeter simple limb, and he's writing 1 millimeter as he's writing it as 1 millimeter. He wants to write down 1 millimeter in symbols, but he's using capital limb. If you use 1 capital limb meter, it says 1 megameter. So we all know milli means 10 to the power minus 3, mega means milli means 10 to the power minus 3, megameter means, remember, the value is 10 to the power 6. Even rather than using simple limb, if you choose the wrong symbol capital limb, it can entirely change your value. 1 millimeter means very small measurement, but mistakenly you wrote milli as capital limb. Instead of writing simple limb for milli, you wrote capital limb for milli. It result a different or a huge value. That idea, right? So that idea, this story write down in the given space. Point number 3, red color pen. Okay, this is the only important point. Red color pen. Okay, point number 3, red color pen. Point number 3, write down. Red color pen, point number 3, write down. Although the kilogram, inside the bracket, simple K, simple G. Although the kilogram, simple K, simple G, close the bracket, is the official SI base unit. although the kilogram, inside the bracket, simple key, simple G, close the bracket, is the official SI base unit for mass, SI base unit for mass, official SI base unit for mass, official SI base unit for mass. Prefixes are never added to kilogram. That is very important point, okay? Prefixes are never added to kilogram. Full stop. Prefixes are never added to kilogram, full stop. Instead, comma, they are always attached to the word gram. Instead, they are always attached to the word gram. Inside the bracket, simple G, close the bracket. Instead, they are always attached to the word gram. Inside the bracket, simple G, close the bracket. The last story, finished. Now we know that, sir, now when measuring the length, the SI unit is meter, right? And when measuring the time, SI unit second. Normally, we are adding prefixes in front of the SI unit. Meter means kilometer, right? Means kilometer. If not megameter, if not, we can tell micrometer. We are adding prefixes in front of the SI unit. If it is second, megasecond, millisecond, megasecond, millisecond, right? Microsecond, gigasecond. But remember, when it comes to the mass, SI unit of mass is kilogram, right? All the previous SI units, when you measure the length, SI unit is meter. When you are measuring the time, SI unit is second. When you are measuring the current, SI unit is capital A, ampere. You added these prefixes always in front of the SI unit. But except mass. SI unit to measure the mass is kilogram, but remember, we never add the prefix in front of kilogram. Remember, SI unit to measure the mass is kilograms. We never add the prefix in front of the kilogram. For example, millikilogram. We don't add microkilogram, megakilogram, gigakilogram. We never add the prefix in front of the SI unit of mass. Okay, that is the only difference. But what we are doing, only for the mass, all the other physical quantities, right, all other physical quantities in front of the SI unit of the physical quantity only, we added the prefix. Only in front of the SI unit of that physical quantity only, we add the prefix. For example, second means millisecond, distance means meter means micrometer, ampere means milliampere, right? Then candela means millicandela, mole means millimole, right? Kelvin means microkelvin, some kind of idea, except the mass. We never add the prefix in front of the SI unit of mass, kilogram. We don't do that. But what we do, only for the mass, we are adding the prefix in front of the grams. We are adding the prefix only in front of the grams. Only in front of the grams. Milligram, milligram, microgram. For example, then what? Kilogram. That is the SI unit. Kilogram, megagram. Do you understand? That is very important point in your MCQs. They can ask the story also. The last theory point, the last point, and finished everything. The last point is, remember, when a unit with a prefix is raised to a power, squared or cube, the prefix multiple, the prefix multiplier is also raised to the same power. For example, now, the last theory point. The last theory point, for example, let's see. The last theory point is, let's say now, right? Now they mentioned there, when a unit with a prefix is raised to a power. When a unit with a prefix is raised to a power, squared or cubed, the prefix multiplier is also raised to the same power. Okay, let's consider now you are measuring an area. That's an area. Area, right? Area. Length is, for example, 1 centimeter. Width is also 1 centimeter. What is the area? We all know area means length into width. Area equals length into width. 1 centimeter into 1 centimeter. Right? Then we are writing the area as, remember, 1 centimeter squared. Right? 1 centimeter squared. You got it? If I'm measuring a volume, length, width and height also 1 centimeter. The volume is, remember, we are writing it as 1 centimeter into 1 centimeter into 1 centimeter. 1 centimeter. Then remember, the volume is going to be also 1 into 1 into 1 is 1. 1 centimeter cube. 1 centimeter cube. Do you understand? Is the idea. Right, the value stories I will tell you next day. How to convert centimeter square into meter square theories, centimeter cube into meter cube theories. I will teach you next day. Roughly remember, these are all the theory points. These are all theory points. I think today the class is very effective. I think we took more time and we discussed the sessions. Right, okay. Listen, then this is the overall theory regarding the unit system. We can have a small, I will plan that. Right, we learned entire theories regarding unit section. The first unit, we completed units theory section completely. Right, then we should do few more questions. Right, in units theory we should do few more questions. Next day we'll plan that question sections, and next day we are starting dimensions. I think all theories I tried maximum to explain everything properly with my best. I hope everyone understood. Right, therefore come classes properly. Right, join live. Don't watch the recording. Right, okay. So we have a very nice plan to be done. There's a very huge plan for you people waiting. So we'll work nicely. Right, then session is completely discussed, all done. And if you have any doubts, you can ask. You can put a WhatsApp message to my WhatsApp number. You can put a WhatsApp message to my WhatsApp number. Please refer these theory points once again. WhatsApp to my WhatsApp number. Right, WhatsApp 075 799 7893. You can WhatsApp this number. Then okay, then story finished. Then we'll see you mostly Friday. We are doing a session, basic math session. Last Friday we could not do because of that connection issue. No? This Friday we can do. Then in the basic math session we will practice some mathematical stuffs, O-level stuffs only. But once again we'll practice some mathematical stuffs and we'll get the idea. So we'll meet you on this Friday. Then have a nice day. Good night.